Good morning, or maybe night or afternoon. I don't know. It's morning for me, so I'm going to use morning. So we are looking at this ellipse. Someone asked about this ellipse question. How do you write the equation of a standard form of an ellipse given the foci and the covertices? Now, I didn't actually talk about what covertices were in the notes, and that might be throwing you off a little bit. Um, in an ellipse, if I were to draw an ellipse like this, right, we said this here was the center. These two around here are the foci, and then we said that these two at the ends are the vertices. Well, the ones that would be above and below the center, those are the covertices, the short ends, like the belt waist of the ellipse. Now remember that ellipse doesn't have to be this way. It could also let's see if I can do this. I don't know if I can rotate it, but the ellipse itself could actually physically be turned on its side, and it would mean the same thing. Yeah, I don't think I can actually turn it. But imagine I took that ellipse. I mean, like, just take your head right now and turn it sideways. That could be the ellipse too, which would cause the vertices to be on the top and the bottom, the foci to be up and down, and the covertices to be on the left and the right. So it just depends on the graph. So with that, that's going to be our first step here. Right, my first step is to do a quick rough sketch of the points that I'm given so I can figure out if my ellipse is a x-axis or a y-axis ellipse. Is it going long on the y-axis or is it going long on the x-axis? So the first two things I'm going to graph are these foci here. Those are my first two graphs. So it says go over 16 and up 5 for the first one, and we'll just roughly put it here. And then go over 16 and up 3, and we'll put it there. I know that's definitely not accurate, but we're going to pretend it's accurate for now. And then it says the co-vertices, remember this is co-vertices, not the actual vertices. Pay attention to this co that's up here that's kind of hidden. The co-vertices are over 16 minus 4 square roots of 5 up 4, and then over 16 plus 4 square roots of 5 up 4. So what it tells me is if I go over 16 and then go up 4, the first one is a little bit less, 4 square roots of 5 less, and the other one is 4 square roots of 5 more than 16, which causes my covertices to be there, which ultimately is going to make it so that I have an ellipse that comes down and goes through that covertice. Sorry, trying to line it up on covertices isn't working. Here, let's just do this. Oh, ooh, ooh, ooh. Ooh, look, the second time. I don't know why I got it much better that time. So that's ultimately what our ellipse is going to kind of look like. The thing I'm still missing, actually I'm missing two things still. The two things I still need is I have to still know where the center's at, which on a graph I know is roughly about here. And I still need to know where the normal vertices are, which we know would be out here and out here. So if I can get those two things, then I can actually go in and solve this problem. So let's start with the first one, the center. Center is pretty easy to find. You can either choose the two foci or the two covertices and find the midpoint of them. Obviously here I'm going to choose the foci because the covertices have those negative 4 square roots of 5. I don't want to even confuse myself with that. So remember to do midpoint. What we do is we take the x's of the foci and add them together. So the 16 and the 16 I'm going to add together. And then you're going to divide it by 2 to find the number in the middle. And then I'm going to take the y values, the 5 and the 3, and add those together and divide by 2. So what I end up getting is 16 plus 16 is 32. 32 divided by 2 is going to give us 16 again. And over here, 5 plus 3 is 8. 8 divided by 2 is 4. So I know now that the center of my graph is at 16, 4. In order to find the vertices, or the vertices, I don't know, that's definitely not right. Just vertices, yeah, that's how you spell it, with the scribble. To find the vertices, that's where we have to use this weird formula. It's a squared plus b squared equals c squared, but what ends up happening is that a in this problem is the c part of the ellipse, and b in this problem is the b of the ellipse, and that's going to give me this distance right here, which just so happens to also be equal to this distance here. So the distance from here to here, even though my picture is terrible, this distance is equal to a, which is also equal to that distance a. So we're going to do b squared plus c squared equals a squared. B squared plus c squared equals a squared is a super important formula to remember for ellipses. You have to remember this. Well, Mr. Knock, what is b and a and c? Well, that's a good question. B is always equal to the distance from the center to the co-vertex. So in this case, the co-vertex is at 16 plus 4 radical 5, 4, or at 16 minus 4 radical 5, 4. Doesn't matter. You can choose either one. I'm going to choose this one that has a positive number. Well, since my center is at 16, 4, the distance between the y's is 0, so you don't even have to worry about the y's. We just have to worry about the distance between the 16 and the 16 plus 4 squared to 5, which they already did for you, right? The distance between 16 and 16 plus 4 squared to 5 is 4 squared to 5. So I know that b in this problem is 4 squared to 5. C is always equal from the center to one of the foci, or a focus, right? So if you choose one focus and find the distance, then you know that that's how far it is for C. Well, again, since our center is at 16, 4, the 16 is already lined up. 16 is 0 away from 16, so we only have to worry about the y's. Well, how far is 5 from 4, or 3 from 4? They're 1 unit away, so I know C is equal to 1. I can then take those two things and plug them into my problem. So I'm going to have 4 square roots of 5 squared for b squared plus c squared, which is 1 squared, equals a squared. And we'll work through this. 4 square roots of 5 squared, you're going to square each of these individually. So 4 squared is 16. The square root of 5 squared is 5. Makes the square root cancel out. And then 1 squared is 1. And multiply here. 16 times 5 is going to be 80. And 80 plus 1 is 81. So I know a squared is equal to 81. Truthfully, you could stop there. If you wanted to keep going and say, okay, well, that tells me that then I square root both sides and I get that a is equal to 9, you're welcome to do that. And I know that went off my screen a little bit, but it really doesn't help us. It's not gonna assist us in this problem, because the actual formula here, now you'd look at your notes and look at your formula. Your formula is that you have x minus h squared with something underneath it, plus y minus h squared with something underneath it is equal to 1. And in your notes it said a squared plus b squared, or a squared and b squared were underneath, but they switch depending on which way is bigger. So what I'm going to do is I'm going to plug in my things. So we know h and, that's supposed to be a k, I'm sorry, not another h and k. We know that my h and k is the center, so this is h and this is k. Always put the x value with the x and the y value with the y. So I'm going to take my little eraser here and we're going to erase a couple things. Let's do medium. I think medium will work. So I'm going to take the h out, and I'm going to take this k out, and we're going to plug in the pieces that we now know. I know that the h was 16, so I'm going to plug in minus 16. And the k was 4, so I'm going to plug in minus 4. Notice that it kind of looks negative in the problem, right? It's x minus 16 and x minus 4, which is weird because this was positive 16 and positive 4. That will always happen. If you plug in a negative number, it switches to positive because it becomes minus a negative. If you plug in a positive number, the negative stays there because it stays a minus problem. So it always looks the opposite of what it is. If the center is positive, positive, the formula is going to say negative, negative. If the center is negative, negative, the formula is going to say plus, plus. If you have a negative plus in the center, then you're going to have a plus minus in the problem. So just be mindful of that. And then it's just a matter of plugging in a and b. Well, if you look at your a and your b, a squared gave me 81. B squared, which we did right on this spot right here, right? B squared gave me 80. Well, which one's bigger, 80 or 81? We know 81's bigger. So since 81 is bigger, that has to go along this long side. Well, is this an x-axis or a y-axis? It's a y-axis. So I'm going to put the y value where the bigger one is, right? So we look here. Here's the y value of my equation is this y minus 4, meaning the bigger value, the 81, a squared, is going to go here. And since the short part is along the x-axis in this problem, then the shorter number, the 80, is going to go underneath here. And again, this is the b squared and the a squared. That's where those two numbers came from, b squared and a squared. But again, you got to just be mindful. Always put the bigger one underneath whichever axis is bigger. If the x-axis is bigger, then the bigger number goes underneath the x value. And that is it. Oh, I see that it kind of got cut off there. The things that's here, I'll just move my face, please. Oh, I have to unlock it. There we go. There's the actual problem. So you can see I've got that minus 1 at the end. Make sure you square both of them. And that's it. That's all you got to know for doing those. Hopefully that helps you out and gets you going in the right direction. Bye, everybody. Oh, you can't see me wave. Bye, everybody.